In this tutorial you will learn how to create sound reactive motion graphics like these, with 100% pure Blender, no add-ons or scripting required. We have three distinct things going on here. The bubbles in the center for the low frequencies like the kick drums and bass, the particles for sounds in the mid-range frequencies, flying faster for louder sounds, and the random red laser lines for bursts in the high frequency ranges. Welcome Blenderheads and the 70% of viewers who are not subscribed yet.
What?
Please do me a favor and don't forget to like, subscribe and drop a comment while you're watching and learning new skills for free. Thank you! If you have never seen geometry or simulation nodes in Blender before, I recommend the playlist linked in the card and video description. Now let's fire up Blender and make some cool audio-based animations! This is Sylvie, and this tutorial has the Sylvie seal of approval. I'm using Blender 3.6.1 for this, and the first thing of course we want to do is get the audio in. But before that, it's important to set the frame rate. Now we're going to do the same thing as in the demo. We're going to have the bass, the mid frequencies, and then the high frequencies. So we're going to use the cube for the bass. Now let's add in an icosphere and a torus for the high frequencies. So essentially what we're going to do is assign the volume of our audio file, the bass part, to the cube. Okay. How do we do that? So we go to, let's go to animation, and on frame 1, so this is important, you have to go shift cursor left. Why aren't the screencast keys showing here? So shift cursor left takes you to frame 1, and on that frame 1 we're going to insert a location iframe. Okay, and then we're going to take the C location. We can turn this into the graph editor, for example, and we're gonna take, we don't need these, we just want the C location on frame 1, and then we go to channel, and here you can go bake a sound to F curves, which is exactly what we want. And then I take my desired music, and in here is where basically the magic happens. So for the bass, for the cube, we only want the bass, and the bass we're going to take from frequency 0 to 300. Let's just do that. And then bake sound to F curve. And you can see we have some stuff in here. Now, of course, this audio file is longer. So let's click normalize and let's see how long it is. And then we're just going to drag our end frame out to cover the entire song. Now we can see here that there's basically almost no bass in the beginning of this song, and then there's some kick drum hits, and then there's quiet again. Now if I hit a spacebar to play, we can see our cube is moving, and it's moving with the bass part of our song. And then when the bass kicks in, we can see it's moving a lot more. However, we can't hear anything yet, but we can fix that. We can go to the video editing part of Blender and bring in the same audio file. Plop that in. Where is it? Oh, of course, I wasn't on frame 1 now, but that doesn't matter. I can just go frame 1, move that to frame 1, and then go back to my animation. And if I hit spacebar now, I hope you can hear it a little bit in the background. I have the music playing and I can hear and see what's happening. So, as I said, this is just the bass. You can see this is reacting really quite nicely to the bass. Now let's do the same thing with the mid range. So let's go back to frame 1. This is important because of the baking, because I think it starts on the frame that you're currently on. And you always want to be on frame 1 so that they all line up. Okay, so icosphere. We need an location iframe. We go to the C location, a channel, bake sound, take the same one, and let's do 300 to, I don't know, let's do 4000. Okay, that would be the mid-range part of the sound spectrum. Bake that in. Okay, so there is a lot more happening in the beginning here, whereas there's almost no bass. Okay, looking good. Now let's do the high frequencies. Again, frame 1, insert location, go to the C location, channel, bake sound, pick the sound, and let's go from 4000 to 20K. And that's it for the high frequencies. All right, so let's see if it works. Oh, let me save first. Let's go back to frame 1, hit spacebar. Okay, so there's a lot happening in the mid-range here, a little bit in the high frequencies, a little bit in the low frequencies, but then when the bass comes in, this is the bass. And the high frequencies are always a bit tricky because there's not that much in the super high frequencies happening, and they're always overlapping a lot with the mid, but that's just how it is. My name is Chris and I make free Blender tutorials. If you enjoy the content, please give the video a thumbs up and subscribe. Thank you. Back to the tutorial. Let's go to geometry nodes because that's where we're going to do most of the work. Over here, I would like to create a new collection. Let's call it audio and take the icosphere, the cube and the torus and just drag it into the audio collection. First thing we want to do is let's maybe take care of the bass. Okay. So for the bass animation, I had those bubbles in the center of the screen. Maybe let's just align our camera. Also, again, we don't have screencast keys are showing up. Then RX90 and GY, bring it out, look through the camera. This is what we're looking at. Now we're gonna need an object for our bass motion graphics. So let's bring an object in. It doesn't matter what, or actually, does it matter? Probably not. Let's just take an icosphere. Okay. Bring it forward maybe a little bit. And on this object here, let's call that base. On the base object, we create a new geometry nodes node tree. And in here, we're gonna now take in the information of our cube, pin this view, so now we can drag in the cube because that's our base audio information and it's stored in the location here. But it's only in the C component of the location, so we have to separate XYZ, and this is now the volume of the bass part of our audio file. Cool. So what do we want to do? We want to probably go into, let's look through the camera once more. Let's maybe scale this up. Also, I should have subdivided this a lot more probably. So let's make it a little bit rounder. Okay, now we're going to distribute some points onto this. So we want to distribute points on faces. And the density is actually what we're going to plug in from our audio information. So when there's a lot of bass happening, then we have more points distributed onto our icosphere. Let's see if it works. So let's go here. We have the music playing. Okay, we can see more bass and we get more points distributed. All right, seems to be pretty cool, but we want to maybe take away the really quiet parts. Now, I didn't find a smooth solution for sort of a high pass filter, but we can always just do maybe a compare and say, okay, if our volume information is less than, I don't know, 0.3, then we want to switch a float value, float. Okay, so if it's less than, we want 0. If it's greater than, we want this. Okay, and then also we should add probably a math node so we can multiply our value a little bit. Bring this over, and this is our density, and let's see. Okay, so when there's almost no bass happening, we have 0 points, and only if our value is above 0.3, we get some points. We can increase this to 0.5. All right, that's the bass information. Now this is just a point cloud. There's nothing to render and we can't actually see anything if we would hit render now. So right away we can do in instance on points. And what do we want to instance? Maybe an icosphere with a few subdivisions. All right, cool. So we have this now. Okay, now for the actual animation, we want these icospheres, the icospheres to like appear when the base hits and then just shrink down to nothing. Okay, let's do that. And we have to do that in a simulation zone. Just a quick reminder, if you have no idea how this works, I have an entire tutorial series looking at the simulation zones and the simulation nodes in Blender geometry nodes. So you should watch those videos first, probably. All right, now let's plug this in. We want to simulate our geometry. The geometry in this case is, like I said, just a point cloud. Okay, now we want the spheres to shrink down. For that, we need to simulate something in this zone over time. Let's give each sphere the information of its size. We can do that by or we could capture an attribute, or we could use a named attribute, but each point in a point cloud has more than just a position. It also knows, it also has a rotation, and it also has a scale, which in case of a point is the radius. So we can go search radius, and we can say set point radius. And let's just start off with a radius of 1. So we have sort of a factor between 1 and 0. Okay, we have a radius of 1. And then over time, which is in here, the simulation. So whatever you plug in here is just for the first frame. After the first frame, you're just simulating stuff here, and none of this input is used anymore. Okay, so inside of the simulation, we want to get the point radius and then set the point radius to a new value. Let's do radius. Okay, so we read the radius and we need a math node, and we can multiply the previous radius by, I don't know, 0.7. And then we set the point radius. Now, of course, this is already working, but it's not showing up because we're not using it yet. Because when we actually instance some icospheres onto our points out here, we can give it a scale and again use the radius. Okay, now this is actually not correct yet, because on each frame we create some points onto our big icosphere, and then we want to animate those. But of course on the next frame they're disappeared again because we create new points onto our geometry. So we don't actually want to plug this into our simulation like this. We want to add the points, the new points, to the existing simulation. So remember, on all of these frames, this is just running in a circle here. This is just keeps simulating on each frame. And we want to have the points from the previous frame and add these points to it. So we need to join geometry, the one from the previous frame, and we add the new points to that. And then of course, actually, we want to set our, we want to set the point radius only on the old geometry. So the new geometry has a radius of 1. The old geometry coming in from the previous frame has a radius, and we change it and set the new radius, and then we have join. And now let's see if that works. Okay. Yes, seems to be working. Okay, so we're distributing points. Now, of course, this is all a bit big, so we can either play with the radius, or we could, let's bring this down a little so we have cleaner noodles, or we could just say, okay, let's start with a radius of 0.5 maybe. Yep, that's exactly what we want. However, there's one thing now that we can't even see, but it is happening. And that is, let me just go back a few frames. Okay, so the bass drum hits, we get new points. They're big. Then with our simulation, we decrease the size by multiplying the previous radius with 0.7. And then they just basically disappear because they get so small. However, they're still there. So this geometry here keeps growing and keeps growing. We just add points and add points on each frame. We don't need to do this. We could just delete some of the points once they're not visible anymore anyway, right? You don't want to just load up your geometry node simulation with millions of points. So how do we do that? Well, we can just go geometry, delete geometry. And what geometry, what points are we going to delete? The ones where we need a math node. Can I just look for less than? Oh, math less than. Cool. Where the radius of the point is less than, let's just say, point, I don't know, 0.1. Let's see how that works. Yeah, pretty cool. Okay. And then down here we can see we have 595 instances currently. If we let it run some more, now we have 727. Okay, let's go forward a few frames. You can see now we have 400, 300. Okay, now we have more again. And then because when the bass drum hits, then we get a lot of points. So maybe this value is a bit much. Let's just multiply it by 2. Let's see. Yep, okay. Looks pretty cool. And we're not just adding new points, we're also getting rid of the points that we can't see anymore anyway. And this is all we need to make sound reactive motion graphics. Okay, now let me open the demo file and show you all the other parts. Okay, this is my demo file, and you can see here I'm on the low frequency object here, and this is exactly the same. Node 3, we take the information from the cube. I called it low, but it's the cube. Okay, so we take the low information, the C-axis, we do our high pass filter here, distribute the points, set the radius, make them smaller over time, or decrease the radius over time. We delete the geometry we can't see anymore. We instance icospheres, and then back here I also set smooth, which you have to do inside of geometry nodes so that these spheres are smooth. And then I also have a material. The material is this one, where I just assign a random factor here to get a little bit of variation. So we have some yellow and some red with this color ramp. And then I use the layer weight, and I'm sure you've seen this before. This is the layer weight, and usually it looks like this. So that gives you the angle of the surface to your camera. And you can turn down the blend, so you can just get the circle basically of the sphere, and if you plug that through a color ramp, you can do something like this, which is pretty cool looking. And then I just use the emission shader, and I don't even know if I need this. Hold on, do I need this? Oh yeah, okay. I use this factor here that gives me just a circle to mix between the emission shader and an empty shader, which gives me the black inside. And this also gives a cool effect because it looks sort of like a cartoonish cloud, because we don't get the full circles where we have overlapping spheres. So I think this is actually a pretty cool shader to create these sort of cartoony clouds. Okay, now go back to geometry nodes. Let's look at the mid. What have we done for the mid? So we're taking the C location from our mid object, which was the sphere. And then again, we separate, high pass filter, multiply. And what I've done here is my mid object, this guy here, is actually an icosphere, a very tiny icosphere in the middle of the scene. And I can emit particles, like all of these dots here, by shooting them out along the normal. So if you have the icosphere, you want the normal would be here and this normal would be here, right? So we can emit particles like this from our original geometry, which is an icosphere, by taking the normal of our icosphere and storing this in a named attribute, and I called it V for velocity. So each of our points that we're emitting on each frame now has the velocity. I also store another attribute called age. Inside of the simulation, I take the age, I add 1, so on each frame, each particle gets older by 1, right? So read, add, store. Again, we have delete geometry here because we want to delete the particles once they leave our frame. So this is the camera frame here. I don't know if you can see this on the recording, but we don't need to make them fly out infinitely. Once they hit outside here, or once they reach the outside of our frame, we can delete them. So that's what we're doing here. If our age is greater than 60, we delete the points. And then, of course, we want to move the point on each frame. We move each point on V. Remember, V is our velocity, which is the normal. So we have a lot of particles flying outwards. And also, V, let me see here, I'm scaling the normal based on, you can probably see this here, based on the C of our music, right? So particles, the V vector, velocity vector, is longer, where the music is louder. And remember, we're just talking about the mid-range frequencies here. So the louder mid-range hits that we have, the longer our velocity is, which means the faster these particles are flying. And then back here, it's same thing. We're creating icospheres, which are all of these little dots. We have set smooth, have a different material. Let's look at the material real quick. The material uses the age to have a color ramp between H0 and H1. So in order to get a factor between 0 and 1, we have to divide the age by 60. Remember, we're deleting the particles after 60 frames, so no particle is ever older than 60. So we add a factor between 0 and 1. So when they're born, they're bright white. And then over time, we have this color ramp, emission shader, and that's it. So if we hit play, this is what we get. You can see we have some particles flying faster and some are slower, and that's just the volume of our mid-range audio. All right, so that's that. And then we have the high frequencies. Let's look at those geometry nodes. High frequency, high. And in here you can see I don't even have a simulation area. On each frame, I simply create 2 random vectors that are just somewhere inside of my frame. So x minus 50, c minus 20, and they're all on the y0 plane. So we just get some random vectors if we look at it from the front. And then we have 2 random vectors, and they also have different values because I plugged the frame from our animation value into the ID here. So we get 2 different random vectors, create a curve out of that, curve to mesh based on a circle, and then set the material to the high material. The high material is just an emission shader with a very high strength, which gives us this sort of laser beam look. And down here, I'm using the audio information again, the C value from the high frequency info. And I say if that is greater than, this is again sort of a high pass, then either we have 0 or that value, which is the high pass, and I use that as the curve circle for this line. So essentially, we get a random line on our screen on every single frame, but on the frames where the high frequency audio is not very loud, the radius is 0, so we just can't see it. All right, So this doesn't even have an animation, this is just like laser light flickering. And if we put it all together and hit spacebar, then this is what we get. Now remember, we got the audio information into these 3 objects here by baking the audio and selecting a certain frequency range. And if you wanted to create a spectrum analyzer, you could do the same thing. Just, I don't know, get 10 divisions of your frequency range and then have bars scaled on the C and have a shader going from green to yellow to red. It's really very easy. That's it. As always, the finished blend file for this tutorial and many more is available to download at patreon.com/chrisp. Thanks for watching. See you soon. Bye.